Alright, so I'm about to take a stab at doing section 1.7. In section 1.7, it's just a review. There isn't anything new. It's kind of a scrambled review of all the problems from sections 1.1 through 1.6. So there technically isn't anything new. So in some sense, it's not a hard section, but in reality, it is a hard section because when we do sections, it's usually you get a bunch of one kind of problem. You just do them again and again and again. And so it's kind of easy to know, once you've done a few problems, what strategy that you need to use to do the next problem. In reality, when we're asked to factor, the problems don't all look the same. And this section, what I've done is taken problems like any of the problems from the first 6 sections and I scrambled them up. And then it's going to be your job to recognize what factoring strategy we need. And that's not an easy task until you've done a lot of factoring. So I typed up a couple of pages to just try to help get your thoughts together a little bit. And I might refer back to these pages as I go through the lecture. I don't really know what's going to happen, but I think that's going to happen. So I start off saying, one of the hardest thing about factoring is just to know what, how to take that first step, what first step is the right first step. Because generally, when students know what first step to take, then they can get the whole problem done correctly. But then if you don't know the first step, then you're just stuck. So I wrote these sheets up, and the first thing that I put down, I even tried to bold it a little bit or cap lock it, is if a problem has a greatest common factor, you just have to get that greatest common factor out first. Methods like bottoms up, if you don't pull out the greatest common factor, they'll give you the wrong answer. And most of our problems, if you don't pull out the greatest common factor, it won't be obvious which technique to use. So anytime I'm asked in the instructions to factor, the very first thing I'll do is look for a greatest common factor. I'll factor it out. The greatest common factor will be part of my answer, but it won't affect the rest of the factoring, kind of the 2 parentheses factoring. And then the only thing we ever did in terms of factoring, we factors problems with 2 terms, 3 terms, and 4 terms. Once we start to get beyond 4 terms, that probably gets well beyond the scope of intermediate algebra. I suppose I could design a problem with 5 terms that is factorable, but that's usually a pretty high level problem. As a matter of fact, to factor some problems, like a problem with 5 terms in a 5th degree, you need something called Galois theory, what that's worth. And I don't know, I took that class my 2nd semester in grad school. So it's pretty, so to do more than 4 terms, just an arbitrary problem with 5 terms, that's a pretty high level problem. We don't deal with it. So everything that we factored had 4 terms, 3 terms, or 2 terms, and I will be consistent with that. I won't sneak a problem with 5 terms, 6 terms, or 7 terms and ask you to factor. I'm not a big fan of grouping, but immediately, if I see a problem with 4 terms, I'm going to go to grouping. That's generally when a problem is given to you with 4 terms, then you're going to factor by grouping. You factor by grouping by, grouping some things in parentheses, pulling out common factors, and then factoring the parentheses that they have in common out. And just real quickly, I wrote 2 problems down here: x squared plus 5x plus 6 plus 30, 6y squared minus 5y minus 4y plus 10. Just because those have 4 terms, I would likely just immediately go into grouping. Sometimes you can avoid grouping by rewriting the problem. Like in this problem, I could add the 6x and the 5x and create an 11x and make a problem that has 3 terms and get around grouping. But generally, I don't try to fight it. If a problem has 4 terms, I use grouping. So that's all I need to say. And then when we get into the section, I'll relive the specifics about how we actually factor with grouping. But at least you should know 4 terms is grouping. And then the last few sections, sections 1.4 and 1.3, I think we factored with 3 terms. And when you have 3 terms, Some of them you use bottoms up, some of them you don't use bottoms up. 3 terms is a time where bottoms up could come into play. So I tried to explain, well, if the problem has 3 terms, we need to classify them. We pull out a common factor. If there isn't a common factor, or if there is a common factor, I look at the 3 terms after I pull out the common factor and figure out if there's a number in front of the first term. If there's not a number in front of the first term, it's a little bit easier. I don't need bottoms up. If I have 3 terms and the first term has a number in front of it, I need to use bottoms up. I did, for each of the problems with 3 terms, I did some problems by grouping. You could, any problem that has 3 terms, factor by grouping, but like I said, I don't generally like grouping, and I avoid it. I only use grouping when I have 4 terms. And when I get 3 terms, I break them into 2 categories. The easier of the category when you have 3 terms look like this: x squared plus 5x minus 6, y squared minus 3y plus 2. What those have in common is what I'm trying to discuss here. They don't have a number in front of the square term. When you don't have a number in front of the square term, you don't use bottoms up. And these are the easier problems because most everything is done for me. I should know what the firsts are when I go to factor a problem with 3 terms that don't have a number in front of the square term or the first term, and I should know what the signs are from this template. The only thing I need to do is figure out the lasts, and we made tables to get the lasts. So problems like x squared plus 5x minus 6, I could factor those pretty completely pretty quickly. In these problems, when there's not a number in front of the x squared or in front of the y squared, I know what the firsts are, and then I have a template for my signs. So here the signs are plus and minus. When the signs are plus and minus, I need a plus and a minus. And so when I have 3 terms, no number in front of the squared term, my firsts come for free, my signs come for free. I'll just make a table to figure out my lasts. And the kind of table that we did is we looked at the last number, we figured out factors of the last number, and then figured out which of the lasts were appropriate. So it's the easier of the problems that have 3 terms. So problems with 3 terms without a number in front of the square term, I should know my first, I should know my last without any work, and then I look at the last number, I make a table if I need to figure out what my last needs to be. And again, I'll get into more detail as I go through this section. I'll do more of these problems all the way out. But now I just want us to be able to recognize what strategy we need based on what the problem looks like. The next kind of problem with 3 terms are the harder problems, and these are problems that have 3 terms, but they have a number stuck in front of the first term. And when you have a number stuck in front of the first term, that's when you use bottoms up. Remember, the steps for bottoms up were multiply, factor, divide, reduce, and bottoms up. So problems like these are stuck using bottoms up, and I don't know immediately what my firsts are. I could know immediately what my signs are. That template for the signs that I did in the last grouping, that template for the signs will work in bottoms up as well. But I don't know what my first should be for certain, and I'll go through the whole bottoms up process if I have 3 terms and there's a number in front of the first term. The last few sections that we dealt with were problems with 2 terms, and problems with 2 terms need to be broken down into squares or cubes. Squares, the letters have exponents that are multiples of 2, like x squared, y to the 4th, z to the 6th, w to the 8th if you wanted to. And they have numbers that are perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So if you have the letters that have exponents that are multiples of 2 and the numbers are perfect squares, then it's a square problem. Square problems, it makes a difference to the sign, because square problems with plus signs are sums of squares and they're prime. Square problems with minus signs I call difference of squares and they factor. So here are an example of squares problems with pluses. They're squares because if I look at the numbers, 9's a perfect square, 16's a perfect square, and the exponent's a multiple of 2. Here, the exponent's a multiple of 2, 49 is a perfect square, and sums of squares are all prime. Square problems with minuses factor, and here are examples of square problems with minuses. They're square problems because the numbers 9 and 16 are perfect squares. The letter has an exponent that's a multiple of 2. Similarly, here the exponent on the y is a multiple of 2. The number is a perfect square. These factor, and how do they factor? You square root any number, you divide any exponent by 2, and you get two essentially identical parentheses, one with a plus, one with a minus sign. So like this would factor into 3x plus 4 and 3x minus 4. So square problems with minuses factor. You square root the numbers. Square root of 9 is 3. Square root of 16 is 4. I divide the exponent on the x by 2. Cube problems. Again, square and cube problems are reserved to problems with 2 terms. If something has 3 or 4 terms, I won't call it a square or cube problem. Cube problems, I can identify them quickly. If I look at the letters will have exponents that are multiples of 3. So x cubed, y to the 6th, z to the 9th, w to the 12th if I wanted. And the numbers will be perfect cubed. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So if I see these kinds of numbers and exponents that are multiples of 3, and I only have 2 terms, then I know I have a cube problem. With cube problems, it doesn't matter the sign in terms of whether they factor or not. Cube problems with pluses and cube problems with minuses both factor. And there's that template for the sign. The template is SOP. In cube problems with pluses, like this problem, the signs are going to be the same sign of a plus sign, which is plus, and then the opposite of plus, which is minus, and then the last is plus. So this is a template for cube problems with a plus. Cube problems with a minus, like that problem, first sign is the same sign as minus, and then second parentheses, the first thing you get is the opposite sign. Opposite of minus is plus, and the last sign is plus. So this is for cube with a minus, and this is a template for cube with a plus. The nice thing about cube problems is once you get the signs, the templated signs in, you fill up the parentheses the same way. These are the problems where I write down what makes each a cube, like x cubed is x times x times x, and 64 is 4 times 4 times 4. And then I fill up the parentheses. The first parentheses I put one of each, and then the second parentheses I start filling them up with pairs. That's a really quick kind of summary of the first few sections, and I'll try to, I think, relive this as we go through section 1.7 and do the problems. So each of the problems just tell me to factor, and I always look for common factors first, so letters that each piece has in common, or numbers that divide evenly into all the numbers that I see. There's no common factor for number 2. It has 2 terms. So if it has 2 terms, it's either a square or a cube problem, and this problem must be a square problem, because to be a square problem, you need exponents that are multiples of 2, the exponent's a multiple of 2, and numbers that are perfect square, and 25 is a perfect square. So this is a square problem, and in square problems the sign's a huge deal, because square problems with pluses are prime, square problems with minuses factor. Because this is a square problem with a plus, there's nothing I can do but say that it's prime. So problems with 2 terms, first I try to separate to figure out if they're a square problem or a cube problem, and then if it's a square problems with pluses are prime, square problems with minuses factor. This was a square problem with a plus, so it's prime. 4 should say 121x squared, and it will say it by the time you print it out. So let's just say 121x squared minus 144. It's definitely not a cube problem because the exponent 2 isn't a multiple of 3. It's not a 3, 6, 9, or 12. So I think it's a square problem. In order for it to really be a square problem, the numbers 121 and 144 have to have nice square roots. So I think this is a square with a minus. And if it's a square with a minus, then it's going to factor into two essentially identical parentheses, one with a plus and one with a minus. I need to square root the numbers, and I need to divide the exponent of the letter by 2. If when I try to square root the numbers I get a decimal or something that still has a square root in it, then it's not a difference of squares. And then I don't know what to do, so it better be a difference of squares. So let me square root the 121. And that's 11, that's a good thing. And I'll square root the 144. And that's 12, that's also a good thing. So this is a square with a minus. It fits the category perfectly. It fits what a square needs to have. The exponent's a multiple of 2. The numbers are perfect squares, which means they have nice square roots. Square problems with minuses, factor. You divide the exponent of the letter by 2, you square root any number, and then you create two essentially identical parentheses, other than one has a plus sign and one has a minus sign. So in the first piece, I'll take the square root of 121, which is 11, and what I get when I divide the exponent of the letter by 2, which is x to the first, those will be my first, because the 121x squared is first, and then the lasts will be the square root of 144, which is 12. That's it for 4. 6 is a binomial, which means it's either a square or a cube problem. It doesn't have a common factor. And the x cubed probably means it has to be a cube problem. To be a cube problem, each of the pieces needs to be able to be written as 3 identical terms being multiplied. And that's not so hard to do. This is a cube problem with a plus because x cubed can be written as x times x times x. 1 can be written as 1 times 1 times 1. So that definitely clues me into the fact that it's a cube problem. Because cube problems, the letters have exponents that are multiples of 3. 3 is a multiple of 3. And the numbers are perfect cube, and 1 is a perfect cube. Cube problems factor, and once I get the template with the signs, I fill them up the same way. So I'm going to get my signs in, and this is a cube problem with a plus, so I'm going to use that template. First sign gets to be the same sign as the original problem. Same sign as plus is plus. Second parenthesis starts out with the opposite sign of the original problem. The opposite of plus is minus. And then the last parentheses, the last sign in the second parentheses is plus. Again, we use the words SOP, or the, I don't know if that's what that's called, an acronym. I don't really think it's even called that. But anyways, I use SOP to help me figure out the signs. And then to fill up the parentheses, first parentheses gets 1 of each. So I should box my answers. That's the answer to problem 4. First parentheses gets 1 of each, 1x and 1, 1. And then I start pairing. Pair of x's, an x times a 1, and a 1 times a 1. First parentheses isn't going to change. It's going to stay x plus 1. Second parentheses, the pair of x's multiplies to be x squared. The x times 1, I could either write 1x or I could just write x. I don't need that 1. And then the last 1 times 1 is 1. And that's going to be the answer to how problem 6 factors. I could check every single one of these by multiplying out my work, and it should equal the original problem. But my videos get to be so long anyways, I'm just going to slow down and not check a lot of things. 8's another 2 terms, so it's either a square or a cube, and when I see an exponent of x cubed, I think it must be a cube, and it is, which means I need to be able to cube root the numbers, and I'm going to go shift cube root 27, so I hit the shift and the square root key, and the cube root of 27 is 3. So that means the 27x cubed can be written as 3x times 3x times 3x. And I'll shift square root to cube root the 64. And 64 can be written as 4 times 4 times 4. So when I go to factor cube problems, I need to write each of the pieces as 3 identical terms being multiplied. And I also need to get my templated signs. So I'm going to put the same sign as the original problem, the same sign as a minus, and then I'll put the opposite sign of a minus, the opposite of minus is plus, and then the last one's always plus. Now I'll start filling up my parentheses. First parentheses is one of each, so 1 3x and 1 4. Second parentheses I'll start pairing, so 3x times 3x, 3x times 4, and 4 times 4. First parentheses not going to change. Second parentheses, 3x times 3x is 9x squared. 3x times 4 is 12x. 4 times 4 is 16. The second parentheses is always prime. I don't have to worry about trying to factor it. I like the way I teach cubes. Back in 1994, my very first semester at GCC, I was teaching at the main campus. I taught cubes and I taught them wrong. I did, well, somehow I started multiplying the term in the middle by 2 and gave all my students bad information, and they might still have that bad information. So once I did it wrong, I figured out a better way to teach it, and nobody teaches this way. I show people this way. I just like it so much better. There's another way that teachers teach using a formula, and that's the way that I kind of gagged on, so I use this strategy for cubes. 10 has 3 terms. I could use grouping for any problem with 3 terms, but I don't like grouping. There's no common factor, so I don't get the luxury of yanking out a common factor. And problems with 3 terms, if they don't have a number in front of the first term, I know my firsts and my signs. Unfortunately, I do have a number in front of the first term. Problems with 3 terms that have a number in front of the first term, I need to use bottoms up. And that's what this is. I have 3 terms, a number in front of the first term, so I'm going to use bottoms up. That's the only time I use bottoms up. First step in bottoms up is to multiply. And very specifically, I'm going to multiply that 8 and that 3. I'm going to rewrite the problem as y squared minus 10y. And when I multiply this 8 by this 3, I get minus 24. Now I'm going to go into factoring this. And for this, I know that my firsts have to be a couple of y's. And I can sneak the template here. The signs are minus and minus in the original problem. So my parentheses have to have 1 plus and 1 minus. So I could get everything but the lasts in. And for the lasts, I'll make a table. My lasts can be 1 and minus 24. They could be minus 1 and positive 24. Trying to search out a 10. They could be minus 2 and positive 12. They can be 2 and minus 12. Getting tired of this already. Oh, but I think I have it. I'm looking for a minus 10. And this pair right here, if you do 2 minus 12, you'll get negative 10. So my lasts are going to be a positive 2 and a minus 12. I could have continued with this table and did the 3 and the negative 8, the 4 and the negative 6, but I didn't have to. As I was going through each line in my mind, I was combining 1 minus 20. I was going 1 minus 24, that's a negative 23, that's no good. Negative 1 plus 24, that's a positive 23, that's no good. And when I got to the one that worked, then I showed why it worked. I'm not done with my bottoms up. The rest of my bottoms up now is to divide. I started off multiplying by 8. I multiplied the last number by 8. I need to divide the last number by 8. After I divide, any fraction I have that can be reduced, I need to reduce it. The first fraction reduces to 1 over 4. The second fraction reduces by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. If you can't reduce the fraction 12 over 8, just enter it on your calculator. Go fraction 12 over 8. Hit equals, and this calculator will reduce it for you. So I've done the divide and the reduce part, and now I'm going to finish off and get my answer by doing the bottoms up part. first parentheses, the 4 I'll bring up in front of the y, and it'll turn into a 4y plus 1. Second parentheses, I bring the 2 in front of the y, and I'm left with a 2y minus 3. I could FOIL this to check to see my answer is correct, but I'm pretty sure it's correct. Let me just FOIL it in my head. 8. It's right. 12 is the first problem that has a common factor, and any time there's a negative written first, you at least have to factor out a negative, and if there's a common factor, do negative in the common factor. Each of the numbers 16, 20, and 6 are divisible by 2. I'm going to factor out a negative 2, and to figure out what goes in my parentheses, I'd go negative 16x squared divided by negative 2. That will leave me a positive 8x squared. And then I'll go 20x over negative 2. That will leave me a negative 10x. And then 6 divided by negative 2 will leave me a negative 3. That could be the problem we just did. I do that sometimes. Oh, it is. Look at that. Well, I have 8y squared minus 10y minus 3. So if I was clever, I would just copy this down and say this is going to be 4x plus 1 and 2x minus 3. I'll pretend I didn't notice that, and I'll go on and factor. So for now, I'm going to ignore the original problem. I'm going to ignore this minus 2, and what's stuck in the parentheses has 3 terms, but it has a number in front of the first term. That locks me into bottoms up. So I'm going to bottoms up this. I'm going to multiply and go x squared minus 10x minus 24. And then I'm going to factor this. And I still remember that I needed a plus 2 and a minus 12. For my last, you can look at my last table to figure out how I did that. And the signs were templated signs. And I'm kind of speeding through this because I just did the exact same problem. And now I'm going to divide. I started off multiplying 8 by 8. I'm going to divide by 8. And then I'm going to reduce. The first fraction reduces to 1/4 plus. The second fraction reduced to 3/2. And then I'm going to bottoms up. It would be wrong if I forgot the common factor. So if I just bottoms up this one and got 4x plus 1, bottoms up that one and got 2x minus 3, and said that was my answer, it wouldn't be right because I've ignored the common factor. I need to get that common factor in my final answer if I don't carry it along the whole way. So the best answer I could come up with for 12 would have the common factor of negative 2, and then what the 8x squared minus 10x minus 3 factors into the 4x plus 1 times 2x minus 3. 14 doesn't have a common factor. It has 3 terms, and because there's a number in front of the square term, it's a bottoms up problem. So the only time I ever get bottoms up is when I have 3 terms and when there's a number in front of the square term. So first step is to multiply. I'm going to get x squared minus 23x plus 60 because I multiplied this 5 and that 12 to get a 60. Now I'm going to 2 parentheses factor this. And this is easy-ish factoring because the first come for free. I get a couple of x's. And my signs come for free. This problem has a minus sign, then a plus sign. So the factors are going to have 2 minus signs. So when I'm into this stage of my bottoms up factoring, I know that I'm going to split the x's into the firsts. The signs come from my templates, and now I'm going to figure out the lasts by doing my factors, and they have to be double minus. So to hunt out my lasts, I'm going to start making a table. I'm going to go minus 1 times minus 60. I don't see a minus 23 there. I'm not going to go further with that. A minus 2 times minus 30. I don't see a 23 there either. Minus 3 times minus 20. Minus 3 times minus 20 is a 60, and minus 3 minus 20 is minus 23. So that's the pair that I need. It doesn't matter which I put in the first parentheses or which I put in the second parentheses, but one parentheses needs a -3, the other needs a -20. So I've got the hard part of bottoms up done. Now I'm going to go into the divide part of bottoms up. I started off multiplying by 5. I'm going to end up dividing by 5. And then in this case, I think I'm going to reduce and bottoms up in the same step and go right to my answer. The first parentheses doesn't reduce, so I'm going to bottoms up it and get a 5x minus 3. The second parentheses, the fraction reduces, and the fraction actually goes away. 20 over 5 is 4. That's my answer. You could FOIL it to check, but it's completely going to work. If you have the time and the desire, if you FOILed this and did first outers, inners last, and combined the outers and the inners, you get exactly the original problem. 16, it's 3 terms. It's not going to be a bottoms up because there's not a number in front of the first term. But any time there's a negative written first, I factor out a negative or a -1 as a common factor. And when you factor out just a -1 or just a negative, inside the parentheses you put the opposite. The opposite of negative b squared is positive b squared. The opposite of positive b is negative 7b. The opposite of negative 12 is positive 12. So it's 3 terms. The -1 is going to stay in my answer, but it's not going to be part of the 2 parentheses factoring. So at this point, I'm ignoring the original problem, I'm ignoring the -1, and I'm trying to break that b squared minus 7b plus 12 into 2 parentheses. Because there's not a number in front of the squared term, I don't need bottoms up. I'm going to throw a couple b's to split the b squared between the 2 parentheses. And then my signs, this has a minus and plus, so my signs have to be minus and minus. And then I'm going to hunt down, figure out what my lasts can be by making, a smaller table than I had been doing. I'll do -1 times -12, -2 times -6, and -3 times -4. Those are all the factors of 12 that have the double negatives, and this is the pair that's going to get me there, because -3 -4 give me the -7. So in one parentheses I need a 3 next to a minus sign, and the other parentheses I need a 4 next to the minus sign, and it just doesn't matter where you go with it. So this would be a completely awesome answer. It's totally correct. It's probably what I might write on my key. But it would also be absolutely okay if you just put a negative sign in and didn't include the 1, and if you wrote the numbers in a different order, would be completely fine too. So some variation of what I have there, either a minus or a -1 in front of the parentheses, and one parentheses with a b minus 3, one with a b minus 4. 18 has a 3-term problem. There's no common factor, and because there's not a number in front of the square term, it's not bottoms up. It has the same template. My template for this is going to be a minus and a minus. And my first, I split the y's between the 2 parentheses. It's just a matter of getting the right lasts. With this 24, I'm going to hunt out my lasts. And I'm being much less elaborate with my tables because most students at some point avoid doing tables completely, and they can do these in their head. I'm just trying to help you if you need to do more work. So I wrote all the factors of 24 that have double negative. Each one of these multiply out to be positive 24. I need to find the pair that give me the -10, and this one's deceptive. The -2 and the -12, because the numbers have the same signs, you add the numbers and they give you a -14. The pair that you need is the -4 and -6. Both the numbers are negative. I add them and keep them negative, and that will give me the -10. Only one of the pairs can ever work. You can never get 2 pairs that work. If you get 2 pairs that work, then you messed up on combining. You maybe added when you should subtract or subtracted when you should add. So in here, one parentheses gets a 4, the other parentheses gets the 6, and you definitely could have written y minus 6 times y minus 4. That would have been equally correct. Hey, 20 is the first problem with 4 terms. When I have 4 terms, I group, even though I might be able to get away with grouping. So 4 terms, grouping, and this is a friendly grouping problem because I don't have any of those horrible minus signs. So I made my 2 parentheses. First parentheses, I yank out a common factor of 5x. When I factor out a 5x, I'm left with an x plus 6. Second parentheses, there's a common factor of a 3. When I factor out a 3, I'm left with an x plus 6. If you don't get the same parentheses, then either you made a mistake or grouping's not working, because grouping needs the parentheses to be the same. Now I'm going to factor out the x plus 6 that they have in common, and I'll be left with a 5x plus 3. And that's my whole answer to problem 20. 22 has 3 terms, but it doesn't have a number in front of the first term, so I don't need bottoms up. I can go straight into my signs and my template. My first have to be a couple of x's to split the x squared between the 2 parentheses, and when there aren't any minus signs, I don't even need to look at my template. I know my signs are a couple of pluses. Now I'm going to try to work on my lasts. So I'm going to look at the 7. The only factors of 7 that have double positive are 1 and 7. This is not good because these factors have to add up to 4 for this to factor, but the only factors of 7 that I know that are double positive are 1 and 7, and they add up to 8. Because I can't find lasts to give me the 4, I wasted my time here, and this whole thing is prime. So you can tell a trinomial, a problem with 3 terms, is prime if when you hunt out the lasts, you can't find the lasts, the numbers that work with the last number to give you the middle number. And it's just prime. (24), there's 3's and y's in both pieces. There's a common factor. Anytime I'm going to factor, I look for a common factor first. In 24, it has 2 terms, which makes it either a square or a cube problem, but it's neither a square nor a cube problem how it's written. Once I pull out the common factor, I'll be able to recognize if it's a square or a cube problem. So I'm going to pull out my common factor of 3 in y. I'll divide the 3 out, take a y away, I'll be left with a y cubed first. And anytime you factor something identically out, you leave a 1 behind where it was at. So the 3y is going to be part of my final answer, but it's not going to impact whether what's left in the parentheses is a square or a cube. And it kind of has to be a cube because the exponent is a 3. So I'm going to treat this like a cube. And I'm going to go to factor the y cubed minus 1 by writing which makes each a cube and templating. Same sign as minus is a minus. Opposite sign of minus is a plus, and the last sign in cubes is always a plus. And then first parentheses, 1 of each. Second parentheses, first pair, y times y. Second pair, y times 1. Third pair, 1 times 1. I've ignored that common factor, but it needs to be part of my answer. And I can insert it here, but at least I need to insert it in my answer. For my answer, I'm going to get 3y, and then y minus 1, and then this y times y is a y squared. This y times 1 is a 1y. I don't need to write the 1, but it's okay to write the 1, and 1 times 1 is 1. So either this or 3y times y minus 1 times y squared plus y plus 1 are both okay answers. It's kind of a matter of preference whether you show the 1 or not. So this is a kind of a nuisance to multiply out to check, but I don't think I've made a mistake, so I'll just keep plodding along and make the video a reasonable length by not checking. Both 26 and 28 have common factors, which means they're not prime. Any problem that has a common factor is not considered prime. In 26, the common factor is a 3. When I factor out a 3, inside the parentheses I'm left with a b squared minus 4. After I pull out my common factor, I kind of look at what's left inside the parentheses and decide if that can be factored more. If it can be factored more, I factor it more. If it can't be factored more, I stop and say what I've written is my answer. This b squared minus 4, that's a binomial, so it means it's either a square or a cube. It's definitely not a cube problem because cube problems don't have exponents that are 2. This is a square problem with a minus or a difference of squares, and it's going to factor by dividing the exponent of the b by 2 and square rooting the number. Anytime I can divide an exponent by 2 and square root a number and there's a minus sign and the number comes out to a nice integer, then that's going to factor. So the b squared minus 4, I'm going to get two essentially identical parentheses, one with a plus sign, one with a minus sign, and the b is going to go first, the 2 is going to go second. I have to have that common factor in my answer. I can't just drop the common factor, even though I don't need it to factor the square in the parentheses. So that would be my answer for 26. 28 has a common factor as well. It's a common factor of a 2. I'm going to factor out a 2 and be left with a b squared plus 4. Now I ignore the original problem. I ignore my common factor. I look at what's in the parentheses, and what's in the parentheses is a square problem with a plus, and square problems with pluses are prime. So unlike the last problem right above it, I'm not going to be able to get two parentheses from the one parentheses that I created on the first step, because b squared plus 4 is prime. But it would be wrong to say the whole problem is prime, because I was able to rewrite the problem with a common factor. And once something has a common factor, the whole problem's not considered prime. And this would be considered the complete factoring of 28. I can't go further than the common factor. 30 and 32, I'm going to do grouping because they have 4 terms. So for 30, I'm going to break it into 2x squared minus 3x. And I stick that minus in the parentheses, a minus x plus 12. First parentheses, there's just a common factor of an x. When I factor out an x, I'm left with a 2x minus 3. Second parentheses, I have to factor out a negative because of that negative written first, and the common factor is a 4. And I can cheat and just write the first parentheses down, or I could do this. I could go negative 8x was in the parentheses. I factored out a negative 4, so I'll divide by negative 4, which will give me a positive 2x. 12 was in the parentheses. I factor out a negative 4, so I could divide by negative 4, and that would tell me I need a negative 3. So the 2x and the minus 3 I need in the parentheses, I got just by looking at the first parentheses and knew that grouping you need the same parentheses. But I could have divided, or I could have done something in my head that was less visual but more clever. So my answer, I'm going to factor out this 2x minus 3, and I'm left with an x minus 4. For 32, 4 terms, so I do grouping. I do x squared plus x. This plus sign doesn't need to be in the parentheses like the minus sign did. First parentheses was a common factor of an x. When I factor out an x, I'm left with an x plus 1. Probably should be writing equal signs because everything's equal to the line above it, but a lot of times I get lazy and don't. Second sign, there's a 12 for a common factor. Parentheses has to be the same. If it's not the same, either I've missed the common factor or I've factored wrong. Now, on either side of the equal sign, or on either side, there's an x plus 1, so I'm going to factor out that x plus 1, and then I'll be left with an x plus 12. (34), there's no common factor, and there's a number in front of, there's 3 terms with a number in front of the first term. That's when I do bottoms up. Bottoms up is reserved for problems that have 3 terms with a number in front of the square term. So first step is to multiply. I'm going to multiply this 2 and that 9 and get x squared plus 9x plus 18. And now I need to factor this. first are easy. I split the x's between the two parentheses. The problem doesn't have any minuses, so my signs are plus and plus. And for my lasts, I need to work with that 18. 18 is 1 times 18. It's 2 times 9, and it's 3 times 6. That's the pair I'm going to need because the 3 plus 6 adds to the 9. You could do 6 and 3, or you could do 3 and 6. It doesn't matter which parentheses you put the numbers in here. When the signs are the same, it's forgiving where you put the parentheses, the numbers in the parentheses. And now I'm going to divide. I started off multiplying by 2, so I'm going to divide by 2. And then I'm going to sneak the reduce and bottoms up into one big step. First fraction doesn't reduce, so I'm going to bottoms up it and get a 2x plus 3. Second fraction, 6 over 2 reduces, and I get an x plus 3. This is going to be my answer. Getting close to the end. Both 36 and 38 have negatives written first, and anytime the first number is negative, you at least have to factor out a negative. If there's a common factor, you factor out a negative with the common factor. 36, there isn't a common factor, but I can factor out the negative 1. When I factor out the negative 1, I put the opposite in the parentheses. The opposite of negative x squared is positive x squared. The opposite of negative 5x is positive 5x. The opposite of positive 6 is negative 6. So I'm going to ignore the original problem. I'm going to ignore this negative 1. I'm going to factor what's in the parentheses. And it's nice factoring because I don't need bottoms up because there's not a number in front of the x squared term. So I'm going to factor this. The first have to be a couple of x's. And the signs, when the signs are plus and minus in the original problem, my signs in my factor are plus and minus. So I'm going to throw down a plus and a minus. And now I'll start working on this 6. I'm going to look at 1 times negative 6, negative 1 times 6, 2 times negative 3, and negative 2 times 3. And I need to get a negative 5. This first one, I need to get a positive 5. This first one, 1 minus 6 is negative 5. The second one's going to work. The third one, 2 minus 3 is negative 1. The fourth one, negative 2 plus 3 is positive 1. The second one, negative 1 plus 6 is positive 5. So that's the one I need. And the 6 has to go with the plus. The 1 has to go with the minus. Otherwise, when I FOIL it, I wouldn't get the right sign on the 5. If you put a 1 in the first parentheses and a 6 next to the minus, when you FOIL it, you'd get a minus 5x. I'm not done because I haven't included the common factor in my answer. And a common factor always needs to be part of your answer. So this would be a great answer. If you wanted to, you could write a negative sign instead of a negative 1. And you could write the x minus 1 parentheses and the x plus 6 second. It doesn't matter. As long as the plus sign's in front of the 6 and the minus sign's in front of the 1, it doesn't matter which you put first. 38, there's a common factor and there's a negative I need to factor out. I'm going to factor out a negative 6. I can do what's inside the parentheses without showing this extra work, but I can show the extra work. What goes first is what you get when you divide negative 6y squared by negative 6. The negative 6's cancel and you're just left with a y squared. What goes second is what you get when you divide negative 30y by negative 6. The two negatives cancel to be a positive. 30 divided by 6 is 5, and I'm still left with a y. And lastly, I put what you get when you divide negative 24 by negative 6, which is a positive 4. So again, now I'm going to ignore the original problem. I'm going to ignore my common factor, and I'm going to try to 2 parentheses factor what's inside the parentheses. Nice thing about it, there's not a number in front of the y squared, so I don't need bottoms up. My firsts are a couple of y's. There's no minus signs, so I know my signs are pluses. And then I look at the 4. I have a choice for my lasts of 1 and 4 or 2 and 2. I need to add the 5. That's the pair that's going to do it. I can put 4 and 1, or I can put 1 and 4. They're both okay. But I can't write an answer without my common factor, so I'm going to sneak that common factor in, and I'm going to call this my answer. So we have 40, 42, and 44, just 3 problems left. And they're all nice problems because I don't see a common factor, and it's 3 terms, but I don't need bottoms up. First one, 40, I'm going to break it down to a couple of x's. My signs for number 40, because this is a plus and a minus, my signs are plus and minus. So I have not only my first, I have my signs in. For my lasts, I have to get that negative 11. I can get a positive 1 and a negative 11, or a negative 1 and a positive 11. I need the one that gives me a positive 10. The top one, 1 minus 11, gives me negative 10. The bottom one, negative 1 plus 11, gives me positive 10. So the negative has to go with the 1, and the positive has to go with the 11. That's done, but you certainly could have written x minus 1 times x plus 11. Both of those are correct answers, and there's one that's not better than another. They're equally good. 42, no common factor, no bottoms up, because I don't see a number in front of the square term. First are a couple of y's. This is the last thing on my template. Signs are plus and minus. Now I'll start working on my lasts. So they could be negative 1 and 24, 1 and negative 24. Oh, I think one of those is going to work. I don't even need to go further. Negative 1 plus 24 gives me positive 23. Almost right. 1 minus 24 gives me negative 23. Fortunately, I didn't have to go through a bunch of different factors. I found the pair quickly. Once I find the pair, I don't go any further. So I'm going to do a positive 1 and a negative 24. Again, you can flip the parentheses around. You could have written y minus 24 times y plus 1. That would be equally correct. Last problem. 3 terms, no common factor. So I don't have to worry about the greatest common factor. No bottoms up because there's not a number in front of the square term. My firsts are going to be a couple of a's. And again, that's the last thing in my template. If you have a minus and minus in the original problem, you get a plus and a minus in the factored answer. So I'll look at my lasts. They could either be a positive 1 and a negative 3, or a negative 1 and a positive 3. Top one, 1 minus 3 is negative 2. Bottom one, negative 1 plus 3 is positive 2. So I need the top one. I need a positive 1 and a negative 3. Or I could have written a minus 3 times a plus 1. That's everything for factoring. The next 2 sections are going to be a little bit different. The next section has problems with equal signs. And up to now, we haven't had a problem with an equal sign, and we haven't had to deal with an equal sign in this chapter yet. And those problems will be a little bit different. And then 2 sections from now, we get word problems. And I never try to make the word problems ridiculously hard, so don't freak out by them. They should be something you can do. I'll go through them in detail enough that hopefully they're not intimidating. And then we get a review, and then we'll be done with chapter 1 and ready for our second test. So if you're not feeling good about this scrambled up factoring, this is the time to hit me up for help, because if you can't do the scrambled factoring, then the next 2 sections will be kind of hard. Chapter 1 test will be kind of hard, and chapter 2 will be hard too, because the key to chapter 2 is your ability to factor. In chapter 2 we factor, and then we do a little bit more after we factor. All right, I'm going to shut it down.